All right, so let's talk about what happens in these graphs. And again, it doesn't really matter whether it's square root, cube root, could be, again, any of the other types of functions we've dealt with. The same transformation rules apply for all of these. All right, so if we're looking, our reference graph, it's a square root. So our reference graph is going to look like this. And so let's take a look and see what happens to this as we make our transformations. So I would always start from, I just kind of work from right to left. I start over here. So what's the vertical shift that occurs in this function? It goes +5 or up 5. So this point right here, this kind of starting point or critical point gets moved 1, 2, 3, 4, 5. And then we move inside our function. So what happens in here? What's the horizontal shift that's occurring? Remember, the horizontal shift is just whatever x has to be to equal, for this whole function to equal 0 inside the parent function. So what value of x would give you a 0 in the parent function? -3. So that means the horizontal shift is negative to the left, 3. So this point here is also going to be shifted 1, 2, 3 units to the left. Okay, now we look outside. Is this going to be a vertical shrink, or is it going to be a shrink or a stretch situation? Remember, it's a shrink if absolute value of a is less than 1. It's a stretch if the absolute value of a, which is your leading coefficient, is greater than 1. So absolute value of -2 fits which of these conditions? Stretch. So this is going to be stretched. What that means is it's going to get bigger faster. So it's going to be a little bit steeper grade to its on the sketch. And then we move all the way to the front. We have a negative, so that means there is a reflection. And the reflections that we're dealing with, when you put a negative in front of this, it changes the y values to just the opposite of what the original y would be. So to switch y values, you would have to reflect across this x-axis. So it's a vertical reflection. Across the x-axis. Okay, so this graph right here is going to be reflected down. So instead of going up and to the right, it's going to go down and to the right. Okay, so let's take a look and see. This gives us our graph. So we went up 5, over 3, and it reflected. It's a little bit steeper, so it's going to get kind of steeper faster. So this is what our graph looks like. Okay, at some point it will pass, or it will cross this x-axis somewhere along the line. Okay, but let's identify. What's our left behavior of the graph now? Does it go up, down, or is it an endpoint? The leftmost behavior is an endpoint. What about the right behavior? Does it go up, down, or is it an endpoint? Goes down and to the right, so it falls. And then we look at our domain. So domain are the x's. What's the lowest x value we could possibly have in this function? -3. What's the greatest x value we can possibly have in this function? Again, it extends here into infinity. -3 is included, so you have a negative or a bracket at the negative. Okay, the range is the y values. What's the lowest y value in this function? What's the smallest number y can be? Again, this continues infinitely here, so -infinity is the lowest y value. And what's the greatest y value? Goes all the way up to 5. It includes 5, can never include the infinities. And so this would be the information regarding your graph.